Hi there everyone, welcome to this week's video where we're going to discuss Leibniz's metaphysical principles. In particular, we're going to be looking at the short selection from your textbook on primary truths. This is Leibniz's example of what he thinks of as a kind of perfect philosophical text. The shortest possible text in which you can derive the greatest number of truths. And I think that if there's anything in Leibniz's corpus that really exemplifies that idea, it's really this short fragment. In only a few pages, Leibniz offers, in essence, the basics of his entire metaphysical system. So, let's get into it. In essence, what Leibniz is attempting to do in the primary truths essay is to explain in more detail a modal concept that we discussed in the last video, namely necessity, and especially not hypothetical necessity, but absolute necessity. What can we know that is absolutely necessary, and how is it that we know it? Leibniz's primary truths is really a systematic attempt to answer this question. Leibniz's answer is that all primary truths, which he conceives of as being mathematics, logic, and metaphysics, are tautologies. So if you haven't taken formal logic, a tautology is just a statement that doesn't say anything more than itself. So A is an example of a tautology, right? A water bottle is a water bottle. A book is a book, right? These are all examples of tautologies. You don't need to go out and investigate the world to know that a book is a book, right? You can simply know it in virtue of its nature or essence, right? Hence, Leibniz designate these as a priori truths. You don't need any sort of experiential evidence in order to know them for certain. The sort of primary example of a tautology would be something like A equals A, right? And another example is A is not A, right? These are all essentially saying the same thing. These are identity statements. So if you were to ask Leibniz a question, which is, how do we know that the a priori truths are in fact true? His answer is that all a priori truths can be resolved into an identity statement. So basic arithmetic, like 2 plus 2 equals 4, is in essence the same thing as A equals A, right? And we're going to see that this is going to involve the principle of non-contradiction. Now, it might give the appearance that given that you're just discussing tautologies, that what we say is not going to carry a lot of content or really be very meaningful. But quite to the contrary, Leibniz is going to maintain that he can prove quite a lot of important metaphysical principles using just this method. His example is what we could call the mereological principle, right? Mereology just means the study of parts and wholes. So this example is a part is less than its whole, right? We can resolve this into an identity statement. And in all cases, Leibniz is going to use this framework of a subject and a predicate, right? A predicate is like a property. It's like a modification or a feature of that thing. And the subject is the substance in which those predicates inhere. So in this case, the predicate, less than its whole, is contained in the subject, in this case, being a part. So you can just know from the nature of what it means to be a part that it has this predicate, this property, this feature of being less than its whole. Leibniz's thought is that all truth works this way. In other words, all true predication involves showing how the predicate is contained within the subject. All truth works this way, even a posteriori truth, but identity statements are able to make the connection between the subject and the predicate explicit. So now with this theory of truth in mind, let's discuss the metaphysical principles that Leibniz thinks that he's able to prove in only a couple of pages, right? So let's get started on this red part of the board. So let's begin with the principle of non-contradiction, which I've written there as PNC. This just states that a predicate and its opposite cannot be contained in the same subject at the same time. So, for example, the wax can't be hot and cold in the same way at the same time. Descartes' wax also can't be tall and short in the same way at the same time. Of course, Descartes describes the process whereby the candle that was originally hot becomes cold, and that it was originally tall becomes short, and so on, right? And so it contained opposite predicates, but it did not do so at the same time. So we can know as a rule for discovering any identity statement that a predicate and its opposite cannot be contained in the same subject at the same time. That's what made us certain that A is not A. Okay, let's move on. The next principle that Leibniz discusses is the principle of sufficient reason, PSR. We're familiar with this one, at least to some degree. Leibniz's formulation of the principle of sufficient reason states that there is a sufficient ground within each subject for all of its predicates. So if, for example, my Diet Coke can is gray, then I can explain from the nature of the Diet Coke can why it had to be gray, right? This is just, in a way, a reflection of this theory of truth that Leibniz has already supposed. That for each predicate, for each property that anything has, you can explain that property in view of the subject for which it is predicated of. And notice this, that the principle of sufficient reason even applies to eternal things, right? So, for example, all triangles, the interior angles add up to 180 degrees when it's placed on a flat surface. Leibniz thinks you can prove that, as indeed Euclid did in the Elements, that it belongs to the nature of the subject, in this case a triangle, to have the predicate of the interior angles adding up to 180 degrees on a flat surface. So the principle of sufficient reason applies to everything, even eternal truths. Now we're going to start getting into a little bit more contentful principles, right? Principles that Leibniz is going to use to argue against various other metaphysical positions. The next principle is the principle of the identity of indiscernibles, or PII. This states that all subjects have one or more predicates distinguishing them from all other subjects. Or in other words, truly indistinguishable subjects, subjects that contain all of the same predicates, are the same subject. So if you think, as Leibniz thinks he's already demonstrated, that each predicate finds a sufficient reason in the subject in which it is a part, right? Then we can define each and every subject, each and every substance in virtue of the predicates that it has. This is what individuates those subjects, makes them different from other ones. Leibniz uses this to argue that there can be no such thing as a vacuum, right? Vacuum is just empty space. Why not? Well, because no vacuum could ever be distinguished from any other vacuum, right? In other words, neither of them would have any predicates or properties that could distinguish them from one another, right? And hence Leibniz calls them a chimera. The same thing is true with the idea of an atom, right? Atoms for Leibniz don't make any sense because atoms on the traditional conception are meant to have all of the same properties or features, right? In which case you could never tell the difference between one atom and any other atom. And consequently, Leibniz is going to argue, generally speaking, that there is no indifference, or there are no equilibria, perfect equilibria, within the universe, right? There are always indiscernibly small differences, right, that perhaps we can't see, right, but make things different from one another. Finally, there's the principle or law of continuity that we can just call PC or LC. It's interesting that this one is often referred to as a law instead of a principle, but we'll leave that aside from the moment. We can formulate the principle of continuity as stating that all change must pass through all intermediating states. In other words, there are no leaps in nature, right? Leibniz draws a number of consequences from this point, right? One is a critique of Cartesian interactionism. So one way that Descartes tried to deal with Princess Elizabeth's objection that he was violating the law of the preservation of motion in the universe is he tried to say that when we use our free will, we aren't changing motions that are taking place in our body in terms of their velocity or momentum. Instead, we're simply changing their direction, right? So before I voluntarily decide to raise my arm, there's motion of animal spirits and so on circulating throughout my body. And what happens in voluntary action is my mind just kind of decides to change the direction of that motion, right? Now, the principle of continuity can explain why Descartes is still violating the law of the preservation of motion, right? Why? Because in order for something to change, for something to change its direction, right, it has to, from left to right, so to speak, right, it has to go through all of the intermediary states, right? And that reveals that Descartes' account still involves a change in momentum, a physical change in momentum caused by voluntary action. Leibniz also thinks that this proves that there's no such thing as action at a distance, right? In order for one thing to affect anything else in the universe, right, it has to make contact, right? It has to travel through all of the intermediary states. If I throw a football, for example, it can't just whiz from my hands to the end zone, right? It has to travel the entire arc to reach that destination. Importantly, the principle or law of continuity doesn't only apply to physical states, but also applies to our mentality. So Leibniz thinks that we have degrees of awareness, right? And very much of our psychic lives is basically unconscious, right? But we come to bring them gradually to consciousness over time. This is an idea that we'll discuss in far more detail during week 10. Finally, this convinces Leibniz that matter is infinitely divisible, or in other words, matter is exactly isomorphic with the number line, right? So we talked about previously how Descartes' account of extended substances drew an analogy between the number line and physical bodies. Physical bodies are mathematically understandable exactly because they take up space, and we can come to understand how they do that using the tools of mathematics, right? Here's another dig at the atomists, right? In the same way that a number line is infinitely divisible, so too, right, matter is also infinitely divisible. And so we will reach no smallest part, no atom from which we could say is the smallest stuff of the universe. Now, that was just a brief explanation of what is an enormously complicated topic. I hope that you found Leibniz's metaphysical principles interesting. Do you agree with his principles? Do you think that they're well-founded? Do you think that he can infer all the stuff that he wants to infer from them? Why or why not? I am very much interested to hear what you have to say, and I will see you in the next video.